Hey guys, Miss A Flag here, reporting from the safe social distance of my family's kitchen. I'm sure you've probably all heard the news by now. We're not scheduled to meet face to face again until April 7th, which is a bummer. I'm gonna miss you guys a lot. But in those 3 weeks, I think it's important for you guys to, of course, maintain your social distance, right? Our physical distance from one another. But I think it's also really important for us to stay in touch. It's important for us to feed our hearts. We need to be talking to each other, stay in touch with one another, even if you can't be physically close. Listen to music, do things that you enjoy, get outside, enjoy the outdoors. And then we also need to keep feeding our minds, okay? Science is the answer, okay? Science is going to help us solve this COVID-19 problem. So I think it's important for us to keep going with our science education. I have my hair up. I have protective eyewear on. So let's go. Let's do it. I have two clear, colorless solutions with me. Shocking, I know, right? I have some sodium carbonate, and then I also have some magnesium sulfate. Today's video lesson is on precipitates. How do we know when a precipitate is formed during a chemical reaction? So I have my two reactants here. You guys know that when I add those together, we are going to get a product. But how will we know if there's a precipitate in that product? Okay. So I know that these two substances both have molecules in them, or ions. And I know that if these two solutions react together, there's a couple of things that could happen. There could be a change in color. There could be the emission of a gas or an odor. We could see some bubbling coming from these substances. There could be a change in temperature, right? Some changes in energy could occur where one could get really warm or one could get really cold, like with our ice cream example. Or it could form a precipitate. Precipitates are formed when two solutions react to form a solid. So I have these two solutions here. I have another receptacle for us to add those substances to. So in your head, go ahead and make a prediction. Do you think a chemical reaction will occur when these two substances are combined? Why or why not? Okay. Let's see what happens. Okay, I see some bubbling. Okay, we have the release of a gas. There's one piece of evidence that a chemical reaction has occurred. We went from having two colorless solutions to now having a milky white solution. Okay, there's a change in color. Now, let's take a look inside. Do you guys see any solids formed here? If I were to strain this through a coffee filter, would we find a precipitate? I don't know. Okay, so I've strained our sodium carbonate magnesium sulfate product into this glass and container, and I just wanted to show you the precipitate. Okay, so it's kind of like a white slime-like substance that's left behind. Okay, so we did form a precipitate. Take a moment to answer these questions either in your head or on a piece of scrap paper. What did you observe when we combined the sodium carbonate solution with the magnesium sulfate solution? How did you know a chemical reaction was taking place? Let's take a look at our chemical equation of reactants and products. How many atoms do you see? Remember, atoms are elements, and elements are represented on the periodic table by their chemical symbol. That chemical symbol is usually represented by a capital letter or a capital letter and a lowercase letter. Our capital letter example is oxygen, which is O. Our uppercase letter and lowercase letter example is sodium, which is represented by a capital N and a lowercase a. If you look at our chemical equation of reactants and products, you can see that magnesium is represented by a capital M and a lowercase g. Also note that the subscript, that little number that kind of sits at the bottom, is actually a clue that tells us how many atoms are present in that molecule. So if you look at the sodium sulfate at the end of our products there, you can see that there are 4 oxygen atoms present in that molecule. Okay, let's take another moment to just examine our reactants and our products from this chemical equation. So we started with magnesium sulfate and sodium carbonate. We added those 2 colorless solutions together, and our product is magnesium and carbonate plus sodium and sulfate. And the image tells us that the sodium sulfate is a clear liquid. So question 5 is asking you, where is the precipitate? Well, we know it's a part of the product, and we know that sodium sulfite is a clear liquid. So we know that the only other possible product that could be our precipitate is the magnesium and carbonate. On a piece of scrap paper, try to see if you can figure out how many of each type of atom appears on each side of the equation. Were the atoms conserved? Okay, guys, last step. You are going to submit a short video or a paragraph to Google Classroom explaining why this science meme is funny but also true. A precipitate formed in my solution. Solid. Okay, do your best. Can't wait to see your faces on video. Be well.